We are going to finish with our chapter 8 topic, subtopic 8.2 effect of force. This is our last subtopic for chapter 8. So we will finish chapter 8 this week, and by next week we are going into new topic chapter 9. Okay, so today's lesson will be short, I guess, and I will show you some videos at the end of this lesson to help you understand more about pressure. Okay, are you guys ready? So I guess ready. Can I hear some response?
Yes.
Good.
Yes.
Okay. Great. All right. So today's lesson is related, very much related to our last lesson. Okay. We are going to look at altitude versus atmospheric pressure. Last class we have gone through atmospheric pressure. What is the meaning of atmospheric pressure and the applications in our daily life. So today we are going to see whether altitude plays a role, have any relation with atmospheric pressure. Can you give me 1 minute? Sorry, yeah.
Joshua nak tengok AI pakai lah.
Okay.
Okay. Macam ni lah. Cikgu kan? Tu ada baby. Benda ni semua.
Boleh kot? Okay, sorry. I'm so sorry for I got some things to do. Someone is coming over. Okay, continue. So today we are going to see the relation between atmospheric pressure and altitude. And we're also going to see the relation between depth versus liquid pressure. Okay? So let's go with altitude versus atmospheric pressure first. Okay, for relationship to know between the relationship between altitude and atmospheric pressure, you have to know that these two words. Okay, you have to know these two words. Okay, peak and food. Do you know what is the meaning of peak and what is the meaning of food? Can I get some response? Hello? Hello? Okay. What's with the emoji, Kssm? Okay, yes. Peak means puncak. Okay, good. Food. What does food means? Cannot hear. Can you hear my voice, everyone? Is it my internet connection? You can hear me clearly now? How about Oshin? Can you hear me now, Oshin? Okay, good. Next time, if my voice suddenly disappear without I'm telling you, you have to tell me, okay? Because I don't know. Sometimes my internet connection is going haywire. Okay. Right. Peak is puncak. How about foot? How about foot? Yes, good. Foot in this picture is kaki gunung ataupun kaki bukit, not our foot. Okay, bukan kaki manusia. Okay, it's called kaki bukit. Kaki bukit atau kaki gunung lah. Depends on our picture lah. Thank you very much. Okay, good. Alright, so these two places between peak and foot, okay, okay, last lesson we've learned that atmospheric pressure act on everything on Earth, okay, act on all objects that are on the surface on the Earth, okay. So today we are going to relate it with altitude. Altitude is ketinggian ataupun altitude dalam bahasa Melayu dia masih altitude, cuma dia adalah ketinggian. Okay, so between at the peak and at the foot of a mountain, can you guess which places have higher atmospheric pressure? Food have higher atmospheric pressure. Anyone else wants to guess? No. Why do you say so? Kenapa food lebih tinggi atmospheric pressure? Why? Why do you say so? Can you guess if you don't know?
Mungkin boleh bersolat sebab
Hello? Can you guess why at the foot is the atmospheric pressure is higher than the atmospheric pressure at the peak?
tuliskan sebut
Why? Why peak, Oshin? Why do you say peak?
Cikgu ada atas ada. Dengan semua mana tentera ada. Dengan anak-anak semua.
Apa nak apa?
Kan.
Tak ada orang jawab. Hello? Just guess first. Daniela, Gwen?
Apa kan? Okey. Sebenarnya dah nak tengok. Okey. Tolak ke tepi dia cukup lah. Kabel dia semua. Faham. Ya bisa.
I'm going to wait. Seriously? This is what happen kalau kita buat satu kelas je.
Saya mute.
Yes, sebab saya nak bercakap kat abang tadi.
Oh, tadi dia dengar ke? Ni kelas apa? B?
E.
Tanya lagi.
Hello? Is anybody here? Tak boleh lah nak record macam ni. Takkan nak bagi dia orang tengok. Tunggu.
Report tak?
Can you answer my question, please? I'm just asking you to guess. If you don't know, then you say don't know. I need to hear some response before I go into our lessons. What is the question just now? Okay. I am asking the atmospheric pressure at the peak or at the foot is higher, and why? Okay, Kssm said because the temperature is higher at the mountain's foot. Okay, yes, it can be. It's a good guess. Anyone else want? So you are saying that the atmospheric pressure at the peak or foot is higher, Kssm? Tahu tak kenapa? Because there are no awang.
Ni big ke?
E.
Awang, ada awang juga ke E?
Tak, sebab tak ada awang lah jadi macam ni.
Oh,
Ha. Satu
Tapi
tak
kalau
ada
E bukan
satu
okey
tak ada
ke?
awang dan tak ada Nelvin, Elsa, orang-orang A. Yang selalu jawab waktu tiga-tiga kelas tu.
Dia
Aprilia Fika ni selalu juga jawab tapi
Di tengah-tengah lah.
sebab dia seorang-seorang jadi
Dia-
macam dia tak nak jawab
Dia
pula.
tak seskema A, tak senakal B. So dia
Peak because udara is smaller. Okay. This is what we are going to see today. The atmospheric at the foot is higher than the atmospheric pressure at the peak. Okay, this is the answer lah. Okay, the atmospheric pressure at the peak at the foot is higher than the atmospheric pressure at the peak. Okay, this is why we are going to see. Okay. As the altitude increase meaning we are going higher lah from the Earth's surface. As the altitude increase, the atmospheric pressure will decrease. Okay, atmospheric pressure will decrease. You can feel the effect of pressure, atmospheric pressure, when you are in an aeroplane. Have you been in an aeroplane before? Have pernah naik aeroplane before? Yes, okay. So when you are in an aeroplane, apa yang awak rasa? What do you feel? Sejuk. Okay, lightheaded. Okay, good. So you sometimes you feel sejuk, lightheaded. Okay, sometimes ada rasa telinga berdengung. Okay, that is all because of the low air pressure. Okay, low atmospheric pressure. You are going higher from the ground, so the atmospheric pressure is decreased. Okay, this is why. Okay, atmospheric pressure is because of the air molecules around us, okay, and the atmospheric atmosphere acting on things on Earth, okay. So at the ground, there are more air molecules compared to the air molecules at the higher altitude, okay. Why? Because of the gravitational pull. Because of the gravitational attraction, gravitational pull. Okay, so gravity also attracts the air molecules. So that causes the air molecules to be more at the foot of the mountain compared to the at the peak of the mountain. Because of the air molecules that are more at the foot of the mountains, okay, so it exerts pressure on the person who is at the foot of the mountain. So the pressure at the foot of the mountain is higher because of the more air particles that exist around us. More air particles. When you are at the top of the mountain or when you are at the peak of the mountain, the air pressure is low because because of the air molecules is low. There are lesser air particles there. When there are lesser air particles, okay, it will causes low pressure. Okay. Closer to the Earth's surface, air molecules are pulled together. Okay, why air molecules are more at the surface of Earth? Because of the gravitational pull. They are pulled by the gravitational pull that causes the rise in temperature, menyebabkan tekanan udara yang lebih tinggi because of the more air molecules or air particles. Okay, when there are more air molecules or air particles, dia akan berlanggar, they will move and collide with each other more. That causes the higher air pressure. Whereas when at the top of the mountain or at the peak of the mountain, there are lesser air particles, so the collision become lesser, so that causes the lower pressure. So at a higher altitude, less affected. So they are less affected by the gravitational pull. So the air molecules is lesser there, air becomes less heavy and it can expand easily and causes lower atmospheric pressure. Okay. So if you can see here, between A, B and C, which position have lower air pressure? A, B or C? Good. Okay. When you are positioned at A, you will feel low air pressure or low atmospheric pressure. Whereas the highest pressure is at good. So the highest pressure is at C. If let's say the question asks you to arrange A, B, C according to the higher pressure to low pressure, how is your answer will be? Arrange from higher pressure to low pressure. Good. Okay, so you will take C, B, and A. Highest is C, and then B, and then lowest is A. Good job. Alright, so about air pressure, if you have been on an aeroplane, okay, let's say you bring a bottle of empty, you bring an empty bottle inside the aeroplane. Okay, so you bring an empty bottle inside an aeroplane, and then when the aeroplane is at the higher altitude, okay, your empty bottle will expand. But when the aeroplane landed, okay, what will happen to your empty bottle? Can you guess? You have an empty bottle, okay, empty bottle on an aeroplane. Okay, when you are at the higher altitude, the shape is still there. The shape is there. Nothing happened to the bottle. But when the aeroplane landed, what will happen? Can you guess what will happen to the bottle? Fell off from where, Cornelius? The cabinet. It can be, but let's say you are holding the bottle. Can you guess what will happen to the bottle? Or if you don't know, you can just say you don't know. Alright. Okay. This is just extra. Okay. You don't need to know this one, but this is an extra thing. Okay. To see if you can relate the class our lessons. Okay. When you have so when you have an empty bottle, okay, at the higher altitude, it is still in a good shape. But when the empty bottle reach on the ground, okay, the bottle will apa kemek cream
Dan.
dented. Yes, the bottle will be dented. Okay, dia akan terkemek. Okay, what's the question again? The empty bottle at the higher altitude will have a good shape, will retain its shape. But when they reach the ground and they reach the lower altitude, they will become dented. Can you guess why? This is an extra question only. I just wanted to see if you can relate our lessons before. Can you guess why it is dented? Anyone? Yes, good. Because of the higher pressure. Thank you. So when the empty bottle at the higher altitude, okay, the empty bottle is does not nothing happen to the empty bottle because of the pressure outside is equal to the pressure inside. Okay, but when the empty bottle reach on the ground, okay, the atmospheric pressure at the ground is higher than the atmospheric pressure at the higher altitude. So the higher atmospheric pressure press on the empty bottle. Because of the bottle now don't have any water anymore, only air molecules. So the inside of the bottle is lower pressure. So that is why the bottle will be dented. So if let's say kalau botol tu dented, macam mana kita nak bagi dia kembang balik? Okay, the trick is you just open the cap. When you open the cap of the bottle, air can now go inside of the bottle, making the pressure inside of the bottle and outside of the bottle same. Okay, so equal. Back to equal. So when there are equal air pressure inside and outside of the bottle will be the bottle will be will return back to its original shape. Okay, that is just extra knowledge for you. Because the gravitational pull, the air temperature in the bottle is low and the high temperature at outside the bottle want to go inside and the bottle will kemek. Okay, Ocean's answer because of the gravitational pull, the air temperature. I think you just need to change something. The air pressure, again not air temperature. The air pressure in bottle is lower than the pressure out at the outside of the bottle. Okay, pressure at the outside of the bottle is higher, so they want to go inside of the bottle and the water will come out. Yes, dented. Good. Okay, you can rationalize you can explain your answer. Good, but you have to change the temperature and pressure. Okay, temperature has lesser effect on the on this in this case. Okay, it is because of the pressure. Okay, good attempt, Oshin. Thank you very much for your response. Okay, now we will continue our lesson. We will go to see the relationship between depth and liquid pressure. It is almost the same thing. Okay, cumanya kali ni kita nak tengok dari ke bawah di dalam lautan pula. Okay, when we see kita tengok lautan, we can feel liquid pressure. Okay, weight of the sea water acting on the body of the diver causes pressure. This is called the liquid pressure. So, bila kita masuk dalam air, there will be weight of water acting on the on our body. Okay, now we will see the relation with the depth. Okay, bila kita masuk dalam, let's say, you are in a swimming pool. Between at the surface of the swimming pool and at the bottom of the swimming pool, which one have higher pressure, if you can guess? Okay, my question is, between the surface of the pool and at the bottom of the pool, which place have higher liquid pressure? The bottom of the pool. Yes, good. Because when you go to the bottom of the pool, there are more water particles above you. So the weight of the water particles acting on your body. So you will feel higher liquid pressure. Okay? Good. So the deeper a diver goes, okay, kalau dalam lautan pula, if the deeper a diver goes, the higher pressure he experience because all of the weight of the water on top of him is acting on the body, on his body. Okay. That is why no one can go, a human body cannot experience the higher pressure at the bottom of the sea if the bottom of the sea is too deep. Okay, that's why we cannot human cannot just deep until at the bottom of the sea. Kalau macam 1 kilometer dia tak boleh, human body cannot withstand the pressure lebih daripada beberapa ratus meter di dalam laut. Okay, because the pressure will be too high. That is why we need to use kapal selam. Sebab tu kalau kita nak menyelam lebih dalam, okay, dalam penyelidikan, okay, penyelidikan laut dalam, we need to use kapal selam to tengok hidupan dekat dalam laut yang lebih dalam because of the pressure is really high. Human body cannot withstand the pressure. Okay, that is also why the dam is empangan. Okay, dam is empangan. That is why empangan punya bentuk, okay, they will have a thicker wall at the bottom of the dam than the at the surface of the dam. Okay, because as we go deeper, we will experience higher pressure. So a thicker wall is needed to make sure that the dam can hold the water. Okay, kalau dia buat ketebalan dinding empangan itu sama atas ke bawah, okay, more likely dinding dam itu akan pecah kalau dia buat ketebalan yang sama. Okay, dia tak boleh nak menahan air tu, tak boleh nak menampung air tu lagi. So the walls of a dam are designed to be thicker at the base in order to withstand the higher pressure at the base of the dam. Okay, that is also the higher pressure also causes a diver to wear a special suit, okay, in order to withstand the higher water pressure. Tapi still, the special suit cannot help the diver to go deeper sangat lebih jauh ke dalam sangat. Okay, they still have limit. Okay, sama juga dengan kapal selam. Kapal selam also have limit sedalam mana dia boleh pergi. Because as we go deeper, the pressure will be higher. Okay, the body of a submarine is made of a strong material so that it will not be crushed by high pressure. Sebab tu kapal selam dia tebal, dibuat tebal-tebal and use a strong material untuk menahan higher pressure di dasar laut. That is why different submarines have different limits as well because they use different materials. Tak semua submarines can go 800 kilometers under the sea. Tak semua. Tak semua submarines can go 500 kilometers under the sea. Depends on the materials that we use to make the submarine. Okay, because of the high pressure. What I wanted you to know is, as we go deeper into the sea or as we go deeper into a liquid container, the pressure will become higher. Okay, because of the weight of the water particles, water molecules. So until here, do you understand? Do you have any question? Do you have any question, guys? No. So if you don't have any more question, I will show you some videos on pressure, and then we will and then you will answer some quizzes, and then it will be at the end of our lesson. Okay, can you see my screen now? Okay, good. So please watch carefully. If you okay, let me give you some ni. This bottle have are made 3 holes. Okay, ada 3 lubang yang dibuat dekat botol ni. Okay, right now it is being closed lah. Okay, ditutup. Okay, lepas ni dia akan buka these 3 holes and you will see something. And I will ask you some question after that. Okay. Okay, so these 3 different holes are located at different altitudes. Okay, at different depth. Okay, so you can see that the liquid is pouring out from the bottle, but they are not going out at the same length. Okay, kalau kita tengok dekat atas sekali, dia pergi jarak yang dia boleh pergi sampai sini saja. Tapi kalau dia pergi lebih dalam, jarak yang dia pergi lebih jauh. Kalau lebih dalam lagi, jarak yang dia pergi lebih jauh. Can you guess why?
Low altitude can cause the high pressure.
Okay, this one we are kita guna liquid. So this is related to the liquid pressure, Oshin. Can you guess one more time? This is related to the liquid pressure. Anybody wants to try? High pressure where, Narisin? Okay, so high pressure at the bottom of the bottle causes, good, thank you very much Narisan and Cornelius. Lubang paling bawah, good, thank you very much. So at the bottom, at the hole that is, the hole at the bottom of the bottle here, okay, we can see that the liquid is going furthest Paling jauh. Why? Because of the highest pressure here. Okay, kalau kita tengok dalam botol ini, okay, this is liquid pressure. At the surface of the bottle, the pressure is the lowest. Here, the pressure become higher, and here the pressure becomes highest. Okay, so that is why the liquid going out at different pace and at different length. Okay, yang mana ada mengalami pressure yang lebih tinggi, dia akan pergi lebih jauh. Okay, pressure yang lebih rendah, dia pergi kurang jauh. Okay, that is why the liquid does not go out at the same length. Itu sahaja. Thank you very much for participating. Okay, and the last video. After this video, we will end our lesson.
Very simple, very user-friendly. We have a very simple water bottle that's been recycled. You can see I pulled the label off just to make it easier for you to see. And you'll notice that I put food coloring in the water just so you can see it better. Normally,
Can you hear the video? Yes, okay.
Be clear, and that's fine. The cap is good to go, and then I have a very simple push pin. So what we want to be sure and very clear about is that air has pressure. Air is pushing down on us every inch of our skin. Air is pushing down, but it's hard for kids to really see that. So we want to do everything we can to show kids that air pressure. And we're going to do it by creating a hole in the bottle with this pin. So I'm going to take this.
So to avoid confusion, okay, last video is about liquid pressure, okay? Liquid pressure and the relation with the depth of the liquid. But this video is the relation between air pressure, only about air pressure, okay? The effects of air pressure in daily life.
This pin, and I'm going to just simply, with the cap on, push the pin right into the bottle. And when I pull it out, you think water will come out of the hole. And let's see what happens. Nothing came out. And I'll put it back in the same hole so you can see. There's a hole there. Now when I apply pressure to the bottle, you'll see it spurt out. When I stop, nothing comes out. And the question is why? Well, the answer has to do with this cap. This cap is keeping all that air from coming in and pushing down on that liquid. So when I take the cap off, air's going to get in, and the air should be pushing down on the top of that liquid and forcing it out. So here we go. Let's take the cap off all the way. You're going to notice I have a trickle. It's coming out on a steady flow. Air is pushing down, pushing it out the hole. So let's stop it. I'm going to cap it, seal it. It stops almost right away. No air can get down and push on that liquid. Air is pushing. All the air in this room is pushing against that hole, and it's preventing that water from coming out. Watch again. Very simple. Air pushes down on the top. It comes out the hole. Cap it. No air can get down to push on the top. Air is pushing on that hole. Nothing comes out. Air pressure. What a cool thing.
Okay, so that is the one situation that is related to our last lesson. That is air pressure. Okay, it can be one of the application in our daily life. Okay, why is nothing came out from the hole when the cap is on? Because the higher atmospheric pressure is pressing on the hole. Okay, dia sama juga macam our condensed milk punya example yesterday. Okay. So, kalau kita buat satu lubang saja macam tadilah. Okay, when only one hole, okay, dia tak susah untuk susu keluar. But when we open another hole, kita buat dua lubang, okay, the air akan tolak milk tu keluar. So, that is why we need two holes for condensed milk untuk keluar. Samalah macam, this is sama macam condensed milk punya example yesterday. Okay, so do you have any more questions, guys? No. Okay, so I hope you understand our lessons today. So, and these lessons, and today's lesson marks the end of our chapter 8. chapter 8 force and motion. Next week we are going into a new chapter, chapter 9 heat. For today's class, I will give you some quizzes. As usual, I will put it in your group WhatsApp. So do it. Take a screenshot of your marks and upload it in our WhatsApp group. If you don't have any more questions, then I guess this is the end of our lessons today. The participation marks will only be given to those who answer my questions today in the chat box. Okay, so you don't need to write down your name because I will just take the name that already there. Okay, so the one yang tak menjawab apa-apa and do not write down anything in the chat box, you won't get any participation marks. You will just get the attendance mark. Okay, if there is no more question, thank you guys. I will see you guys next week. Thank you.
Thank you, teacher.
Welcome.